let's see the differentiation matrix. We know the differentiation matrix is seen yesterday, how it has been obtained. So the differentiation matrix is obtained for the order 3. If it was obtained for order 3, then we should have 3. It is of polynomial 3 means we should have update these vertical or column axes as A0, A1, A2 and A3, and these would be 1, t, t square and t cubes. And this all represents this represents how it was obtained. A0 is there only in the first column, then in the second column it would be when we multiply A0 1, so we should get this first A0, then A1 t this way, then A2 t square. So in this way we have written that unit matrix, identity matrix here, and we have converted, and it is of order 4 into 4. Now in order to obtain the integration matrix, let's consider this equation. Now what should be the things? So the equation would be, now we are finding the integration for the polynomial of the order for the degree 4. So for the fourth degree, for degree 4, let's find what is the integration matrix. So if we are considering the degree of our polynomial as 4, so we have to go from A0 to A4, so t to the power 4. Then certainly we'll be having 5 rows and 5 columns, so that A0, A1t, A2t square, A3t cube in this way. So it is a 5 into 5 matrix. So each of them, now this was given as P1, P2, P3, P4 in this way in the last understandings while deriving the matrix for differentiation. Now here similarly in that equation, let's say in place of P1 we can use y1. y1 is 1, means we are assigning the values to this equation. Now this has been written as y1. y1, the coefficient of this A0, it is 1. The coefficient of this A1 is y2, which is equal to t. Similarly, y3 is the t square, y4 is t cube, and similarly y5 is going to be y5 is t to the power 4. And we know that our operation is integration operation. So when we go for integration from 0 to t, when we do the integration from 0 to t of these individual values, so we were differentiating these equations. Now here we are integrating. So when we do the integration of these, we'll get the integrations of these would be done in this way. Now 1 into dt is t. The integration of the second one is the integration of t into dt is equal to. So in that way we need to go ahead. The integrations of these, integration of from 0 to t, each of this y1 t dt, it would be y2 t dt, it would be in that way. So the integration of y1 of t or y1 is equal to, it is represented as, now let's say A is our integration operation, a y1, let's refer it as a y1. A y1 is equal to this much, and which is equal to t, which is equal to y1 is a 1. So integration from 0 to t, y1 is 1, so what is the dt, which gives, or we can write d tau also. So let's write it tau because limit is t, so its value is t. Similarly, when we do integration, means ap2 is equal to t square by 2. It is t square by 2. ap3 is equal to now ap2 is t square by 2. ap3, when we do the integration of this, it is t cube by 3. Similarly, fourth one is t to the power 4 by 4. ap5 is t to the power 5 by 5. Now this first one, apy1, which is equal to t, can be written as y2. So I mean apy1, ay1 can be written as y2. ay1 is nothing but y2. Similarly, we are ay1 is t, ay2. So last was differentiation, we have learned it with respect to p. It could be p's, or we can write ay2 t square by 2. So this ay2 is nothing but t square. T square is nothing but y3. So we can write this one as y3 divided by, now this ay3 is nothing but t cube, which is nothing but y4, divided by 3. And ay4 is nothing but, it is t to the power 4, which is nothing but y5 divided by 4. By using this, we can write the integration matrix, which is now, let's call it as, it is a integration. Now the first column 1 0 0, this all. Now as we know that our ay1, now in the integration, now this is just a simple matrix. So before it is the polynomial matrix. Now the differentiation matrix would be, here ay1. Now the first row would be ay1 here, ay2, and so on. So these ay1 is nothing but y2. So what is y2? y2 is nothing but ay1. This is our y1, y2, y3, and so on. Now ay1 is nothing but, it is y2. So y2 is this. Means we should write 0, 1 and 3 zeros. Similarly, our ay2 is y3 divided by 2. So what is y3? This one is our y3. So this y3 is 0, 0, 0, 0, 1, but ay2 is y3. y3 is 1 divided by 2 eternally. Then rest would be zeros. Similarly, our ay3, this is ay2, ay3 is y4 by 3. y4 is this one. So let's write 0, 0, 0 as these first elements, y4, and this becomes 1 by 3 it is supposed to, because it is y4 by 3, so 1 by 3, 2. And similarly the t4 means y5, this y5, this ay1, now y2, y3, y4 it is. Now ay4 is y5 by 4, y5 is this one. So y5 is having the last element as non-zero, this 3, 4, and last one is 1 by 4. Now we have reached the degree 4 here, because it is t to the power 4, so we'll stop, we don't go for, because already we have replicated t to the power 4. So we have to stop this. It is actually a 1, 2, 3, 4, 5. It is 5 by 4 matrix. So integration is not a square matrix. It is a 5 by 4 matrix for the degree 4. The same is visible here. The next point is regarding this integration and differentiations. Now differentiation and integrations are the inverses of each other, as we know. Then how to prove that one? So to prove that one, that integration and differentiations are the reverse processes of each other, we'll consider a 4-degree differential equation also. A 4-degree differential equation will be a 5 by 5 matrix. So which runs like for 3 degree it was from 1 to 3, it was a 4 by 4. If it is a 5, then it is a 5 by 5. If it is a 4th degree, then it is a 5 by 5 matrix. And integration matrix, just we have seen, this is our integration matrix. When we multiply both of these, when A differentiation gets multiplied with A integration, then we are getting a unity matrix. As we know, we are doing the differentiation of, as we do the differentiation, A differentiation into A integration. A differentiation is a 5 by 5 matrix, and integration is a 5 by 4 matrix. And as these are true, so after doing this differentiation and integration processes, like multiplying these two, we know A differentiation is having its first column as a 0, so we get a 4 by 4 identity matrix as the result of this. So A differentiation into A integration is a 4 by 4 identity matrix, and from this we conclude that differentiation is the left inverse, means we can multiply, like A differentiation has to be taken first, so differentiation matrix has to be taken first, and then it is to be multiplied with A integration. We can't do the reverse process, like we can't multiply like A integration into A differentiation cannot be done, because it will not satisfy those multiplication criteria. The number of rows and columns may confuse us or will not give us a proper result. So the conclusion is the differentiation is the left inverse. It has to be taken left side of the integration. So differentiation is the left inverse of integration. Rectangular matrices cannot have two-sided inverses, certainly. Our integration is a rectangular matrix wherein m is not equal to n. It is a 5 by 4 matrix. So it cannot have both the inverses, like both the left as well as right inverses. So that is the conclusion regarding this. Then The next point is regarding the rotations, projections and reflections. We consider an identity matrix. The identity matrix of 2 by 2, the 90-degree rotations. We know that what is rotation. The rotations, projections onto the x-axis and reflection through the 45 degrees line. Their matrices are simple. We know after rotation how this Q is obtained. Just the important thing is the Q is the name used for rotation. For projection we use P. So this is 0, 1 and minus 1, 0. How does it come? We know, we have seen it in the linear transformations. What is rotation? Like 0, 1 on the x-axis is going on to like from the y-axis it goes to, sorry, this 1, 0 from x-axis it goes to y-axis, and from y-axis it goes to minus x and y. That is, it goes to minus x. So as we know this, we need to understand a little bit regarding the rotation here. Now what is rotation? And this rotation, let's see this. Let's take this, a diagram. Let's say this is a two-dimensional thing and it is our x and y. If initially we consider the 0, 1, 0 vector, let's say it is 1, 0 vector, 1, 0. This 1, 0 vector I have to rotate by some angle. If this vector which is lying from 0 to, let's say, this point, and this point is given by 1, 0, I want to rotate this one by an angle theta. Let's say I want to move this one by an angle theta, means when I move this vector by an angle theta in the anti-clockwise direction, then the vector will be here. And remember that the amplitude of this one will not change, still it would be of the same magnitude as it was. And when we project this one on either side, let's draw it a bit bigger to understand. When this 1, 0 is moved by an angle theta, then let's say this will be its representation. Let's say it takes this much of value. By an angle theta it is moved. Now when we move the vector, its dimension or its length will not change. The length of this one will be same, but it will have its two axes. Like it was a single dimensional, actually it is a two-dimensional, but one was there, the other quantity was 0. But now when we rotate, now it is lying, it is having both the values as non-zero, and this quantity, suppose if this is r, we have the habit like if there is a vector r, then this component is given by r cos theta, and the other one is given by this. The vertical component is given by r sin theta. We know it is given as r cos theta, and this component is given by this much. Vector is given by r sin theta. So this point is given by, now the value of r is 1. So we don't have to write it as r cos theta or r sin theta. It is 1 into cos theta. There is no meaning in writing because x-axis we need to write first. So it is r cos theta, which is nothing but 1 cos theta and sin theta. And to make the writing easier, we are writing it as C, comma S. C stands for cos theta and S stands for sin theta. The same we are writing. So when we are rotating the vector, this one which is there on the x-axis by an angle theta, it will have both the components x as well as y as non-zero, and the x component is cos theta, y component is sin theta. Similarly, if the thing is here, if the vector is lying in this way, if the vector is lying along the y-axis, if the vector is lying along the y-axis, when it is rotated by an angle theta, then it will go in this direction. It will take up this way. Its amplitude will not change. Now it is moved by an angle theta. Then what about its components? So this is its vertical component and this is its horizontal component, but with the vertical axis it is making an angle. So this value is, let's say its magnitude is 1, then it is 1 into cos theta. The vertical factor becomes cos theta, and the horizontal value, this value is given by sin theta. So this point is nothing but the side we know it is minus of x. So as it is minus of x, let's write it as minus s for sin theta, comma this plus, because it is positive y-axis. So let's write it as c. So minus sc. Our unit vector, which was 0, 1 and 1, 0. The unit vector which was our unit vector 1, 0. 1, 0 means this place. 1, 0 will become cos theta sin theta, and the second one 0, 1. So this point is represented by 0, 1. So this becomes minus sin theta and cos theta. So the same we are discussing here. When the vector is rotated a 0, 1 first basis, the 0, 1 is the first basis of this identity matrix. When it is rotated by an angle theta, then it gives the components cos theta and sin theta, and the 0, 1 is other component. When that is rotated by an angle theta, it gives us minus sin theta and cos theta, the same whatever we have done. So this 1, 0 has given Cs and 0, 1 has given minus Sc. Now our rotation matrix, which is represented by Q, or rotation matrix, sometimes we write R also in this way, but we are using the Q notation throughout. Now the next things we need to discuss are, does the inverse of Q theta and Q minus theta is true? Means, does the inverse of Q theta is Q minus theta? So Q theta, we know it is Cs minus Sc. Then what is Q of minus theta? Q of minus theta is, now here the point 1, 0 was moved in the anti-clockwise direction by an angle theta. Now instead of moving it in an anti-clockwise direction, if we move in the clockwise direction, means instead of moving in the clockwise anti-clockwise direction, if this 1, 0 vector, if this 1, 0 is moved in the anti-clockwise direction, in the clockwise direction instead of anti-clockwise, now this is making an angle theta. Now this 1, 0, the first basis, will become, it will have its components as, now we can resolve. Again, this is what? R cos theta. It is nothing but R cos theta component. So it is C, let's start. And this is certainly yes, but plus or minus. It is minus. Means the Q of minus theta. Now Q of minus theta, when we do it in a reverse way, in a clockwise, it is rotated, then this 1, 0 will become this C and this S is minus. Similarly, when the point 0, 1, will lie on the y-axis. When it is rotated by theta, this becomes C, and this would be, yes, both would be positive, but this vertical one is C and horizontal one is yes. So this becomes yes C. When we see that, so it is CS minus SC, it is C minus S, yes SC. When these two are multiplied, we are getting an identity matrix which proves that Q and Q of theta and Q of minus theta are inverses of each other. Then the next thing we are understanding is Q of theta is the rotated matrix. Does the Q theta of this square, does it equal to Q of 2 theta? Then even the same Q theta is multiplied and the thing says that it is true. So Q square theta, Q theta the square is equal to Q of 2 theta by multiplication. And even the product of, let's say, if there are two variables or two angles of moments, one is theta and another is phi, then the product of the first rotation matrix and the second rotation matrix, is it equal to the sum of both the rotations? That is also true. So this we can verify with the trigonometry. I don't think much of the complexity is there here. So C square, now here during the multiplications, so cos square theta, cos square theta, cos theta, cos theta, cos square theta will get, and this minus sine square minus this, so it will make cos square plus sine square as 1, and other things would be like easily understandable. I hope the rotation is understood today. We can see in the next class.